Hello everyone and welcome to the channel. If you like puzzles or if you'd like to see me struggle to solve one and have a laugh at my expense, then you're at the right address. So please like and subscribe. Today I'm going to be trying my hand at Tenet by Teal. If you'd like to give it a go, there'll be a link in the description below. If you do, please let me know how you fared and what you thought of it. Alright, let's read the rules. Normal Sudoku rules apply, so 1 to 9 in every row, column and box. Light blue lines are Tenet lines, both a ten and a palindrome line. Each line consists of one or more non-overlapping continuous regions, which sum to exactly 10. The sequence of digits on a line must read the same from either end of the line. Digits in a cage sum to the clue in the top left. Okay. Let's see. Tenet lines. That's a new one for me. So these are Tenet lines, which means that they're both a 10 and a palindrome line. Each line consists of one or more non-overlapping continuous regions which sum to exactly 10. Right. Irrespective, of the boxes. It's not that this is 10 and this is 10. It's just this could be 10 and then this could be 10, for instance. But they're at the same time palindromes. Okay. Right. But if they are palindromes, then they should have the same, because we can put 5 and 5. Okay, right, but these are the same as these, for instance. Okay, right. So in this one, for example, we either have these three sum up to 10, and then we have to repeat them exactly in the reverse order and they would be equal to 10, or you'd have this is a 10 and this is the 10 and they will be exactly the same, and these will have to be a 5. Right. Okay. But in this one, well, this one has to sum to a 10 because there's no way around it. And since right. So we do get our first digits because they have to be one. They should be consisting of one or more non-overlapping continuous region which sum to exactly 10. But they're at the same time a palindrome. To be able to read this one in both sides, those two have to be the same. And the only two digits in a Sudoku whose sum is 10, as in one digit multiplied by 2, is 5. Because believe it or not, 5 times 2 is 10. So these two are 5 and we're off. Excellent. We got something. Right. But I was going to say this one, since it's as well a palindrome, it means that these two should be the same because they have to be the same. But we still don't know if it's this plus this equal 10 and this plus this equal 10 or the whole thing equals 10. Right. We don't know that. But we do know that these two are the same. I'll give them a color so that we remember. That doesn't apply here. Here we have the same 3. So it's 6 in total. It's the same as this one. So it's either a set of 3 or it's a set of 2 regions. Right? Because it couldn't be 4, for instance, and 2. Because if this is 4, this would have to be 1, 2, 3, 4. And there's no way of making this a palindrome anymore. Oh, we know. Oh yeah, of course. Yeah, I'm not gonna color everything, but yeah, those have to be the same. So they're either 5 or they're part of these. So that's the easiest way to see it. Right. But here we know that these are the same and they're both equal to 10. Because now there's no other way to do it. There is no other way to do it. Okay. Well, no. I was going to say, could it be a single region? But no, if it's a single region, then it's 1, 2, 3, 4, and the palindrome breaks. Okay. And the same here. Those are 10 and they're exactly the same. Okay. Right. Right. So these digits are here somewhere. I don't know if that's helpful yet, but that's what it is. And this is not a 5. That's not very helpful, but as in, I was going to say it's not a 5 because of this, but it's not a 5 because there are 2 of them, and this whole thing has to add up to 5. Okay, what could it be? Well, 3 is still quite a lot of options, right? 1, 2, 7, 1, 3, 6, 1, 4, 5, and 2, 3, 5. Oh no, hold on. What am I talking about? We have to start with 2 similar. It's not an exclusive one. We need the same digit twice. But that doesn't help, does it? I mean, it only tells us that these are 1, because then we'll have 8, 2, then we'd have 6, 3, we'd have 4, or 4, then we'd have 2. I think that's it. Right. Right. So if we repeat, this would have to be either an 8 or a 6 or a 4 or a 2. Okay. Right. Right. Do we know what that is? What's in this cage? We don't really. All we know that it's not 1, 3, 5. Okay. Can it be 2, 3, 4? It can. It can. Okay. Does this work? Ah. I see. Those have to be a 5, won't they? Right, that's why. Okay, because these digits are exactly these digits. Let's give them a color. But if they're here, then they have to be here as well, because that's the only place we can put them in box 3. But that means that we need to fit the 5 here somewhere, and that on those 2. And this is the only place where the 5 would be. Okay. Well, that's not true. Well, yeah, it is. Because we can't put it here. Can't put it in the middle because, well, no, what am I? It's not just that it's a palindrome. It has to be continuous of contiguous regions. So they have to be next to each other, the 5 on this line. And that's the only 2 that are next to each other. So these are 5s. Okay. There is that. There is that. But then we know that we can't put the 5 here. Can we? Do we? Well, yeah. Because this has to be 2 regions equal to 5. Because like we said, it can't be 1 region. Can it? Why am I saying it can't? It can, of course, because they're again not in the same box. So it can be 3, 2, 3, 2. Fair, but it still can't have a 5. It still can't have a 5. So this is a 5. I'm not sure I grokked this still properly. Think I'm confused between palindrome and this 10 lines that I've never seen before. But right, that's why we're here, to wade through the puzzle and see if we can make sense of it. Okay. Right. But it means that these two are here. Yeah, of course. Okay, so these two cells are these two. So one of those two cells is going to be from 1, 2, 3, and 4. But that's not helpful yet, I think. Just means that these are going to add up to 10 as well. Maybe that's useful. I don't know. Well, there is... that is something that I haven't thought about yet. Because this is 10 and this is 10 as well, which means that these have to add up to 20, because then we have here 25 in total. And the sum of all of these digits should be 45. So if this is 10 and this is 10, that's 20, 25, so we need 20. That's not very restricted yet. But if we look here, we have 14 plus 10 is 24 plus 5 is 29, so we need 16. Still not very restricted, is it? Okay, right. We are getting somewhere, because these two have to add up to 10, and these no, they don't have to. But these two and these two, again, for the same reason, we can repeat the digits. I have to keep that in mind. So this could be 1 4 1 4 or 3 2 3 2, whatever. But whatever they are, they have to repeat here in these two. Okay, right. Except here we know that these add up to 10 and they're exactly the same, so these add up to 10 as well. They're again exactly the same. Okay, so let's maybe pencil mark this one here to see how it interacts with this and these two, because we do need, I think I see it already. We do need one lower than 5 and one higher than 5 here, right? So since we already need one lower than 5, and here's one lower than 5 already that we've seen, then we can't have 3 lower than 5 here. So 2, 3, 4 is out of the question. And it's easy to see as well, because if we put 2, 3, 4, this would become 1, and then we don't have any number lower than 5 to use to make this 10. Right. So 1 to 6 is the candidate, and we can do that by process of elimination, because 6 is the only number higher than 5 that can be used to make 9 with 2 other digits. 7 would need 1 1, which is not possible. 9, of course, is not possible, and 8 would need a 1 0, which is as well not possible. So this is 1, 2, and 6 must be. So this isn't 1 or 2 anymore. Okay, right. But this one can't be 1 and 9 anymore. It can't be 2 and 8, because we've used the 1 and 2. It can't be 6 and 4 either. So these are 7, 3. which means that all of these are 7, 3. Okay, so this is now a 4, which gives us a 4 here too, and that's 8, and we need a 2 to fix that, so this is not a 2. Okay, so far so good. But like we said, those two have to appear here. So this has to have a 4 now. And that's the only place to put that 4. Okay. Right. Still doesn't solve anything, but since we've put the 4 here, we know that this is a 4 because of the palindrome rule. But now this is either a 1, which would make all of this a 10, or 6s, which would give us 2 10s. Right. Okay, now we know what these two are, and they are 8 and 9. We have 1, 2, and 6. And, well, yeah. Now we have to have the same ones repeating here, so 4, 8, and 9. And that's as well 4, 8, and 9. And this can't be a 4. Right. Okay, but these two have to be here. And they have to be either 10 or 5. 5 would give us 4, 1. But 10 still have all kind of options. Okay. Can we say anything about this one now? Not really. Still the 1 and the 6 are useful. That one is not useful yet. What about this? Well, can still have the 2 5s. But can we have 10? I believe we can. Right. Sip of tea. Not sure where I should look next. There's a 4 here. Let's pencil mark a few things. There is a 4, but besides that, yeah. Still don't know if this is 5 or 10. If it's 5, this would be 24, and it would leave us with 21, which is still plausible. And if it's 10, this would be 24, 29, and this would be 16. We don't know what that is, though, do we? No. We don't. But this couldn't be 2, because it has to repeat here. So we know that for sure. And this has to be these. Oh. These 3 have to be these, because there's no somewhere else for them to show up. And this would have to be those two, right? Okay, so we're alternating again like we did here. Does that help? Does that help? Not really. Let's take these colors off and color the other ones so that we see if we can find something. Right. So these are here. This one is here. Okay. And that means well, I don't know what it means. Does this work? 9? Yeah, it does. I'm stuck, I think. Something somewhere is eluding me. Something somewhere is eluding me. There's a 2 here. Does that matter? Does that mean anything? Not really. So 2 leave us with 12. 3 and 9, that's still possible. Still possible. Probably I should figure more of this. The question is, do we need 5-5 or not? Probably don't really. Right. Well, we know that one of these is a 5. That doesn't help. What about here? This can't be 5. This can't be 5. We can't put 5 on these. So one of these is a 5. Yeah. Still not helpful. And I'm back. As usual, doesn't matter how short the video is, I will be interrupted. And that was a few hours interruption on top of it. Alright, where were we? We wanted to figure out where the 5s were and if we needed a 5 here or not. Okay, let's say that there are no 5s. So we need here 3 digits to repeat again here, so they have to be distinct, that sum up to 10. Right, so what do we have? Well, 2 is out of the question and 4 is out of the question. So 1, 3 and 6. Is that possible? Yeah. What else? That's about it. 1, 3 and 6. Am I missing something? I don't think so. We can't, of course, start by 3 because even if we do 3, 5, it's already 8. And we'd need the 2. So it's 1, 3 and 6. Right. I need to just recalculate that. I've just restarted. I'm afraid in the best of times I mess these things up. So 2 can't be used and 4 can't be used. So yeah, that leaves us with 1, 3 and 6, which comes up to 10. But if we had 1, 3 and 6 here, would that be okay? Because this would have to be 2 and this would have to be 7. But besides that, is that an issue? I don't think so. That's possible, I'm afraid. That is possible, I'm afraid. Right. Does it have any effect on anything else? So we're gonna need 1, 3 and 6 here, but sure, that shouldn't be a problem. Right, I don't see a problem with it. Okay, and if these were 5s, then these would be 5s. That's okay, right? That is okay. That is okay. Is there any other place for the 5s? Didn't consider that. I mean, it would have to be here. If it's not on this, then it has to be here, which means that it will have to be here. Well, that's not a problem either. Mille milliards de mille savoirs. What else? What else? Well, the 18 I haven't looked at, but that's because it's 18 with 4. It's going to be 100 possibilities, with no exaggeration. Can we have the 5 here? It would leave us with 13, so that's still almost anything. Yeah, not sure. Not sure. Right. If this is 6, this is 6 as well. So we can't have a 6 here, right? And if this is 6, we'd be needing 4, so 3, 1. Is that okay? This would be a 6. Right. That would be okay. 6 would need a 3, 1. There's no 6 here, but do we need a 6 here? I don't think so. We'd have a 3, 1, but they can still be here. There's no real need for a 6 here at all. Okay, but we can't have 4, 5 or 6. Is that a problem? I don't think so either. So we can still have 3, 2 and 9, for instance. Right? Yeah. So 3 and 9 and the 2 here. Or the other way around. I don't see a problem with that. What am I missing? What am I missing? We said these 2 have to be here, but that was more than possible, because we could have the 4, 1. Can we have the 4, 1? So that would be 1. No, that would be 4, 1, 1, 4. Ah, no, we can't have the 4, 1. There's already a 4. Right. Ah, so these are 10s now, because it can't have the 3, 2. There's no 3 here. I see. So these are now our 10s, and they're specifically not the 3, 7 10s, but besides that we don't know much, do we? See, it can be 9-1, 8-2, and 4-6. No, it can't be 4-6. Fine, we can get rid of the 4-6 from here. No, get rid of it. Okay. And these are then 1, 2, 8, and 9. For what it's worth. For what it's worth. Okay. What else? What else? Can this be 1 and 2? Yes, it can. I don't see a problem. We still have 17 or 16 with 3. Can even still have the 5 and it will be okay. Okay. So what else? What else? That's it. We just got rid of the 4 and 6 here. What does that mean? What does let's hold on. Are there any other things that I forgot? There's the Tenet lines, both Ten and Palindrome. Okay, and then that's it. Digits and cage sum must go to that's it. There are no more rules. No knight move, no anti-king, whatever it is. To my utter dismay. Sip of tea. Those don't have any relationship except they're the same. They don't have to be in the same order, that's for sure. That's for sure. We know that there is another 8-9 here, another 3-7, and another 1-2-6. So I am missing something. Something to do with the what's that called? I have no idea anymore. This relationship between the different columns. Doesn't matter what it's called. I must be missing something. I must be missing something. There has to be a 1-2-6 here. So there has to be another one here though. Isn't there? So there are 3 1-2-6 everywhere. Or 1-6, you know what I mean? It's 3 cells with a combination of 1, 2, and 6. Not very helpful. Not very helpful at all. Right, this couldn't have 2 on it. Is that something? So this is 2. Yes, this is something. Yeah, it's as simple as that. Because we couldn't put 2 here or in any of these places, then we can't put it here either. Because remember, this is a palindrome. If a 2 appears here, it has to reappear here. And we can't put 2 here, so 2 is in one of those, which means that this couldn't be 2, which means that this is a 2. Not that that's going to open the puzzle. Oh, you know, how do you say that? Break the puzzle open. But it's 1 digit, and an easy one at that I didn't see. Okay, anything else we can say about that? Yeah, you can't put the 4 here either. For exactly the same reason. Because now you have a 4 here then. Which means that this isn't a 4, and this is a 4. Again, great, it still doesn't Doesn't resolve it, but fine. We're getting somewhere, I guess. Is there anything else? We can put the 5. Yes, we can put the 5 where we said we could put them. Right. But if we couldn't put the 2 and the 4, then it would become a 1, 9 or 3, 7. Is that an issue? It can't be 3, 7 because it would break this one. Progress. So if this is 5, 5, then it will have to be with a 1, 9. Right. And that is an issue because come on, there must be an issue, a reason. I don't think that there is, unfortunately. 9 and 1 here have no effect. Oh, they would be in those two, of course. This would be a 5. And here 9 and 1, I don't see why we couldn't have 9 and 1. They're not on the same. They're not in the same box. They're not in the same row or column. Right, and the 1, 3, 6 option is still okay. I don't see why we didn't really do anything to stop it, did we? We didn't do anything to stop it. 1, 3, 6 here. Wherever it is. We'll just make this one a 7 and this one a 3. Okay, so this couldn't be 3, but it could be 1 or 6. I don't see an issue with that. Is there? If this is 1 or 6, this would be as well a 1 or 6. So we couldn't have 1 here. Okay. We can't have 1 or 6 anymore in this row. Is that an issue? Is that an issue? And this would be a 1, 6 as well. So we wouldn't be able to put it in this row either, or in that column for that matter. Again, is that an issue? I don't think so, at least. No. 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 These have to be exactly the same, which means if these are from 1, 6, they would be the exact opposite. And nothing. And nothing, I think, in any case. Is there a relationship with this? There's still that one. But I don't think it's... Am I overthinking this? I might very well be. But if there is an easy place to look, I don't directly see it. I don't directly see it. Is there an issue with this one being 1? Don't think so. I don't think so. 2, 7, 3, 6, they both should be okay, right? 2, 7, yeah. 3, 6, yeah. Don't see an issue with that. Right. Right. It's more complicated than I thought it would be, Mr. Teal. Mr. Teal. Those we have looked at, I don't think there's any connection between this and this. that I can see anyway. The 5s we've already discussed. We've already discussed the 5, right? Yeah. If I could just resolve, or at least reason my way into knowing whether this has 3-2 regions or 2-3 regions, if that makes sense. So 3 regions with 2 cells each, or 2 regions with 3 cells each. That would solve most of the puzzle, I think. But I don't see it. I don't. It's either 5s with 3 7s. No, not with 3 7s. With 1 9s, right? Yeah. It's either 5s with 1 9s or or 1 3 6. I'm now looking at the 1 9s again, because this would be 1 9, this would be 1 9, all of those would be 1 9. I'm gonna just pencil mark it in a bit just to see. So there would be, I can't put any 1 9s here, but that's very obvious. But I need another 1 9 here then. Is that it? Is that it? Where do I put the other 1 9 here? I don't know how if that is actually correct or not. Because this could be 9 1, right? And I don't need anything here. Then I would need it here, and that is plausible, unfortunately. If this is 9 1, then this is 8 6, and you'd have a 9 1 here, and this would be as well 9 1. And that is no problem. That is no problem. Right. Pity. A pity. Before we roll back, anything extra we need to think about with the 9 1 that I'm not seeing? Does it interact with the 1 6? I don't think so. 1 9 1 6. No, this could be 9 6. No problem. This would be 9 6 2. Right. The only thing is that if these are 9 1, then these are definitely, no, not even that. I wouldn't know what that would be. That could still be 1 9. 1 9, yeah. Or the other way around. No. Okay. I really need to find something, because we're at 43 minutes. And it seems to me like we're still starting. It's not the puzzle's fault. Can't blame the puzzle for my amount of gray cells. Right. Okay. The only thing that I haven't really exhausted yet is those cages. But I can't for the life of me think of a reason why anything wouldn't work in these. I really can't. Six would need 1 3. That's the only one that could have some problem, but I don't know what. 1 3, this would be 6 as well, so that doesn't matter. Gonna need a 1 3 here, so this becomes a 7 2. Is that an issue? I don't think so. Right, the 14. The 14. It has to be made up with 2 of the pink and 1 of the blue. Let's have a look. Well, 14. 9, 3 and 2 would work. 7, 6 and 1. We can't have 7, 6 and 1. Yeah, we can have 7, 6 and 1. Of course we can. 7, 6 and 1. No. We need 2 pink and 1. Yeah. 6, 1 and 7. Okay. We can. Right. So now we have, what did we have? 9, 3 and 2, 7, 6 and 1. What else? Is that it? 9 and 7 is already too much. 8 and 7 is already too much. Okay. 9 and 3 and 2 we already had. That's about it, right? 8 and 3 would require another 3. Not possible. Okay. So now we know these are from 8. No. There is no 8. 9, 3 and 2, and 7, 6 and 1. That is it, right? That is it. Am I mistaken? We said the 8 doesn't work with anything because 8 and we need 2. Yeah. 8. No, we need 6 with the 8, which we can't make. The 9 needs a 5, that works. 7 needs another 7, which works. The 6 needs 8, which is only the 7 1. Yeah. Right. Okay. Is there any of those that doesn't work for some reason? 9, 3 and 1. 9, 3 and 1. We can put them in any combination as well. This is not gonna be useful, is it? 9, 3 and 1. So we could have the 9 blue and 3 and 1 from the pink, or just have the 9 from the pink with one of the 3 and 1 from the pink and the other one in blue. That's way too many options. Okay. What about the 7, 6? No, it's 9, 3 and 2. Okay, but it still doesn't make any difference, does it? It does not. What about the 7, 6 and 1? Well, if it's 7, 6, 1, we might have a small problem because we can't put 6, 1 here. So we're gonna need the opposite of what these are. But that's not gonna work. So 7, 6, 1 is not good. Right. Because this is both are either 6 or both are 1, which means if they're both 1, we don't have a place for the 1. If they're both 6, we don't have place for the 6. So this is not 7, 6, 1. So this is 2, 3, 9. Hallelujah. Hallelujah. Okay. Right. But we don't know what... Well, do we? Do we? We do have a 167. 1678. These, right? 1, 6, 7, and 8. Okay, now we're getting somewhere. Now we are getting somewhere, I think. I hope you can't hear my neighbors tearing down their house, but if you can, apologies. This one, what could this one be? Well, we said if those were 5 and 5, then it couldn't be 7 and 3. It had to be, drum roll, 9 and 1, which is possible, so it's still the 1. And if they were 3 of them, then we definitely can't have the 7 and 8. Ah. Okay, so this isn't 7 or 8. This is 1, 6, which means that these aren't 1, 6, which means that this is a 9. And this is not a 9. Which means that this is a 3. Which means that this is a 2. I'm gonna stop with the which means. 2, right. So this is, there's a 3, 9 here somewhere. Okay, this is 7. This is 8. Right. So we know the same here, 3 and 7. Okay. Okay, and this would become a 1, 6 as well, because of that one. So now here we have a 7, 8, 2. Okay, right. Right. Now we've resolved this one though, because the only way to have 10... Ooh, hold on. Yeah. I was worried. No, this still works. I didn't mess it up. The only way to have 10 now is to have 9 here and a 1. So if this is 6, this is not a 3, 1. So this is 1. And which means that this is 1, 2, and this is 6. And this is 6. Aha. Which means that this is a 1, 3, 6. Because it couldn't be 4, 6 with 5s. Okay, that's interesting. That's interesting. Let's continue with those. Those are not 8. This is an 8. Okay. Right. 1. Not a 1 or a 2, so a 6. And this is a 2. Very good. This is 6, 3, 9. Except this one can't be 6. Okay. I can take the 4 out of here. Okay, so now we know this is 1 and 3, so this is 1, this is 3, this is 1, this is 3. Okay. Okay. We know that these aren't 1 anymore, so it has to be an 8-2 combination. And if it's an 8-2 combination, this is 8 and this is 2. This is 8 and this is 2. Okay, so the 2 is here now. This isn't an 8. Neither is this one actually, so this is an 8. Okay. Alright. This resolves this one and this one. Do we have all the 2s? I think we do. Very good. Very good. Now we know that these are 5s. Well, they're not 5s, but you can pencil mark 5. Okay, what else can we tell about anything? There's 16 here left. That's still quite open. There's a 1 in here. Can it be in that cage? It would be 3 and it will leave us with 15. 15 can't be 7 8, but it could be a 9 6 still. So yeah, that's not a problem yet. We have a 1 here. This is resolved as well. Right, so this is 1 2 3 1 3 4. Okay, which leaves us here with 7 8 and 9. This one can't be 7. Okay, and this is then 5 8 and 9. That's it. That's it. Okay, and this is everything, isn't it? Pretty much. Well, not an 8. Okay, I will not pencil mark it. Well, it's only 3, isn't it? I should pencil mark it. 5 7 and 9. No, there's no 5 either. It's only 2 7 and 9. So I have no problem pencil marking cells that have 5, but I get to the one where it's only 9 and I decide, nah, that's a bridge too far. Okay, what do we have here? 7 8 and 9. Okay, this isn't an 8. This is an 8. This isn't a 7. At least it can't be a 7. Anything smarter than pencil marking everything now? Should be, right? Or not? Not yet. Let's continue this one. 4 we have, 5 we have, 6, so it's 7 8 and 9. Right, not 7, not 8. Okay, this isn't a 3 anymore. This isn't a 3 anymore. What about the 8? Well, still lots of possibilities for 8, isn't there? Unfortunately. Yeah, those two. Hold on a second. We have, so there should be an 8 here, so this can't be 8. If this isn't 8, these are 7 9, so 7 9 pair. So this is an 8. And that doesn't work. I'm missing something. The 6, of course. The 6, of course, which is here. Ooh. Did I mess it up? Or is it still okay? No, I think it's still okay. Except now we know that this is a 7. And those are 5 8 and 9. Yeah, that makes sense. This isn't a 7. Right. This isn't a 7. But that's it. Looks like it. It looks like it. Okay. What else? What else? Do I have to start looking at this now? Am I forced to? If this is a 5, then we need 11 here. What could it be? Well, it could be a 4 7, if I see that correctly, which is still possible, unfortunately. Okay, one of those is a 6. What else can we say about this? We can say that this is not a 9. Not exactly earth-shattering, but it isn't a 9. those could be a 7 still. Okay, what about these two? Well, 7 or 9, right? Right. That's not helping. It can't be still be that difficult. I'm just can't see the forest for the trees, I think. Am I missing still anything? No, we did do all the Tenet lines are now established and accepted as tenets of the Sudoku faith. Well, alright, let's continue the pencil marking because there must be something I'm not seeing. Right, 3, yeah. 5 we already have. 6, yeah. 7, and then 9. Whoa, that's still can be a lot of things. What about this? 4, indeed. 5 we already put it there. 6, yes. 7, no. 8, no. And 9. Alright, this one isn't too bad. Alright, there's no 8 here. Not that fixed anything, or it did not. Okay. Okay, one of those is an 8. Does that help? Don't think so. Okay, let's see those. 3, yeah. 4, not 5, not 6, 7, yes, and 9. Ooh, those can still be anything. Disgusting. Okay. We do need 16 here in total. Can we have a 9? 9 would require a 7. Yeah, 3, 4. 3, 4. Can we have a 7? 7 would require a 9. Yeah, 4 and 5. Can we have a 1? 9 and 6. Yeah. Everything is possible. Everything is still possible. Yeah, I wasn't afraid, but I thought that this cage was maybe useful towards the end, but we're not even there yet. That's weird. That is weird. Must have missed something or another. Something or another. Where we have there's only one obligatory here. Okay. What is it that I'm not seeing? What is it that I'm not seeing? Oh, well, there's a 7 here. See, it can be that simple. It can be that simple. So this is a 5, which means that this is a 5, and that one is a 5. Okay. So now we do have a 7 and we need 11. The 11 is only 4 and 7, right? As far as I can see. 9 doesn't have a 2 to go with it, and the rest, yeah, 2. Yeah, it is a 4, 7, which means that these are not 4, 7 anymore. Ah, and this is a 9. This is a 3. This is a 1. Okay. This becomes a 7. This becomes an 8, and this becomes a 4. Okay, those couldn't be 4 anymore, or another way of saying it is, where is the 4 in the 7th column? It's here. These aren't 4. This is a 6, this is a 9, 7, 3. Right. Has to be resolved now, right? Yeah, this took much longer than it should. Apologies for that. I think not actually grokking that the restrictions for 14 had a huge impact on this cell here. Well, that took me a while, and then afterwards the usual not seeing obvious Sudoku and simple logic, but that's, you know, if you've been here for a while, you've gotten used to it already. If not, welcome to the channel. Right, well, moment of truth, let's submit it. Yes, it was really nice, Mr. Teal. Thank you for sharing, and I hope that you liked it as well. If you did, please like and subscribe and maybe share, and I'll see you next time. Bye bye.